What if I told you that one of the most interesting, or perhaps even greatest discoveries in human history lies right in our solar system? It's not light years away, but only 1.4 billion kilometers from Earth, a place most people have never even heard of. A small, icy moon orbiting Saturn, long considered completely uninteresting, yet it's one of the most promising places in the solar system where extraterrestrial life could exist. Its name is Enceladus. Even today, very few people know about Enceladus, which I find a bit strange because Enceladus fulfills almost all the conditions that life needs to arise: liquid water, chemical energy, organic compounds. So, if life were actually found on Enceladus, even just in the form of the simplest microbes, it would change everything. It would be proof that life isn't a cosmic fluke, but a principle. That the universe isn't empty, but teeming with life. And that we, humanity, have never truly been alone. So, is there extraterrestrial life on Enceladus? Before we delve deeper, however, it's worth taking a brief look at what Enceladus actually is. Because at first glance, it seems anything but special. Enceladus is one of over 140 known moons of Saturn, and with a diameter of just 500 kilometers, it's a rather small moon. To give you an idea of the size, it would easily fit in Germany, with some space to spare. Its surface is covered by a dense layer of ice that is so bright and smooth that it reflects almost all sunlight. This makes Enceladus one of the most reflective bodies in our entire solar system. It was discovered back in 1789 by the astronomer William Herschel, but for centuries it was considered boring. A white ball of ice without any noteworthy features, somewhere on the edge of the Saturnian system. That changed abruptly when people took a closer look, because the surface of Enceladus is anything but lifeless. Especially at the South Pole, something fascinating is visible. Long, parallel cracks in the ice, which scientists call tiger stripes. They are each about 130 kilometers long and several kilometers wide, and they glow. Compared to the rest of the surface, these stripes are significantly warmer, a clear indication that something is happening deep inside. And it is precisely from these cracks that something happens that is unique in the solar system. Enceladus erupts. Enormous jets of water vapor, ice particles, and organic compounds shoot from the South Pole far into space, some reaching heights of over 400 kilometers. These cryovolcanoes, or ice volcanoes, function similarly to geysers on Earth, except that instead of hot water, frozen material from the moon's interior is forced outwards. The driving force behind this? Saturn's tidal forces. The giant planet pulls and pushes Enceladus with each orbit, like a kind of cosmic putty, generating enough heat to keep the ice inside liquid. Everything it ejects upwards doesn't simply disappear into nothingness. Most of it disperses around Saturn and becomes part of the giant ring known as the E-ring. For a long time, Enceladus was little more than a footnote in astronomical catalogues. A small, bright, icy moon among dozens of others. Inconspicuous, unexplored, uninteresting. No scientist would have seriously bet that it, of all things, would one day revolutionize astrobiology. Then came Cassini. The NASA probe launched in 1997 and reached the Saturnian system in 2004 after a 7-year journey through space. Its mission was wide-ranging: Saturn, its rings, its many moons. Enceladus wasn't initially the focus, but during its first flyby in 2005, the instruments registered something unexpected: a thin atmosphere, unusual warmth at the South Pole, and then the geysers. What followed was one of the most exciting moments in modern space exploration. Cassini flew directly through the geyser-like plumes several times and analysed what Enceladus was hurling into space. The results were unequivocal: water, salt, organic molecules, molecular hydrogen. Ingredients that in science evoke only one association: life. Suddenly, the focus shifted from Titan or Europa alone to this unassuming little moon. Cassini delivered data until its controlled crash into Saturn in 2017, data that continues to be analysed today. And the more researchers analyse it, the clearer it becomes. Enceladus was never boring. We just hadn't looked closely enough. As we know, water is the fundamental prerequisite for life as we know it. And this is precisely where the extraordinary nature of Enceladus begins, because beneath its frozen surface lies a global, liquid ocean. Not a small puddle, not a local melt, a world-spanning ocean that envelops the entire moon. But how do we know this? The first clue came from the plumes themselves. Liquid water ejected into space has to come from somewhere, but it was only through precise gravity measurements by the Cassini probe that the full extent became clear. The probe registered minute variations in Enceladus's gravitational pull, variations that can only be explained by a massive subsurface ocean. Estimates suggest this ocean lies beneath an ice sheet approximately 20 to 25 kilometers thick and is itself up to 40 kilometers deep. That's more water than one would initially expect for a moon of this size. But the truly crucial question isn't whether this ocean exists. The question is, what does it contain? And this is where it gets really interesting. Cassini flew through the plumes and analysed the composition of the ejected material right there on site. What the instruments measured caused a stir among researchers worldwide. The water is salty, has a slightly alkaline pH, and contains dissolved minerals. This sounds less like a dead ice sea and more like an ocean in active contact with its rocky bedrock. This leads to the most important finding of all. The seabed of Enceladus apparently contains hydrothermal vents, places where hot, mineral-rich water emerges from the rock, driven by Saturn's tidal heat. On Earth, such deep-sea vents are known as hotspots of life. Without sunlight, under extreme pressure, in total darkness, and yet they teem with microorganisms. Chemolithotrophic bacteria, which don't need sunlight but obtain chemical energy from the rock. Enceladus presents the exact same scenario. Molecular hydrogen, detected in the plumes, is a particularly strong signal. It is produced when hot water reacts with silicate rock, a process called serpentinization. And this hydrogen is a direct energy source for certain microbes. On Earth, there are entire ecosystems that depend on precisely this. What Enceladus demonstrates is remarkable. An ocean doesn't need a sun to be habitable. It needs water, chemical energy, and time. And Enceladus apparently has all three, and has had them for millions of years. Many moons and planets in our solar system are considered potentially habitable. Europa, Titan, even Mars are frequently mentioned. But Enceladus has an advantage that none of them possess, and this advantage is crucial. It brings its ocean to us. While one would have to drill through kilometers of ice to reach the ocean beneath Europa, Enceladus voluntarily ejects its core into space. A space probe doesn't need to land, drill, or dig. It simply needs to fly through the geysers, and it will have a sample from the interior of an alien ocean. This is unprecedented in space exploration. That's precisely why Enceladus is currently attracting so much attention from scientists. With the right mission, equipped with modern mass spectrometers, the geysers could be analysed for biological signatures, for amino acids, cell membranes, patterns that indicate living or once living organisms. The technology already exists. What's missing is the mission, and that mission is being planned. Concepts like the Enceladus Orbilander, a combined orbital and lander mission, are under serious scientific discussion. A launch would theoretically be possible this decade, but arrival in the Saturn system wouldn't be until the 2040s at the earliest. So, it's not a sprint, but a long road. But it could be the most significant one humanity has ever travelled. The discovery of life on Enceladus, in whatever form, would confirm one of the central assumptions of science, that life arises where conditions allow it. That Earth is not a special case, but one example among many. And that the universe, however cold and empty it may seem from the outside, could be far more vibrant at its core than we have ever dared to imagine. A small, icy moon on the edge of the Saturnian system, inconspicuous, far away, long forgotten, and perhaps the most important address in the entire universe. I hope you enjoyed the video, and I'll see you next time.